Okay, so we just finished a discussion that was really about a priori or logical means of obtaining probabilities, right? So we had, how did we know? We just assume that all of these are equally likely. Okay, so we didn't test it. We didn't test a real die to see if they were actually all equally likely. We just assumed it. So that's called a priori. And now, a lot of times, though, we don't have that situation. We don't have that luxury. So this is called empirical probability models, which are when you're testing. So in problems in which it is difficult or impossible to obtain probabilities for the experimental outcomes by logical reasoning, we can sometimes obtain approximate values for these probabilities by performing the experiment repetitively. So performing it many times and then checking the relative frequencies. The more times, the better. We can then use the relative frequencies of the sample points. So how many times did the one, if we were checking a die, we would see how many times does the 1 occur, how many times does the 2 occur, and so on. So we can use the relative frequencies of the sample points as approximate probabilities. Probabilities obtained in this way are called empirical probabilities. So for example, if you take a thumbtack, and I ask you what's the probability that it will land point up versus point down, we probably have no idea, right? We can't say, oh, they're equally likely, or we don't have some kind of a priori model for this. Okay, so what's the alternative? The alternative is to test it. In other words, empirical probabilities. A thumbtack tossed 2,000 times lands point up 910 times and point down 1,090 times. Find the empirical probability of each outcome. So we use the relative frequencies for the empirical probabilities. So point up, the probability of point up is approximately, so we're using the empirical relative frequency as an approximation to the probability, is 910 over 2,000, which is 0.455, and point down is 1090 over 2,000, which is 0.545. Okay? Or a second example would be a loaded six-sided die is tossed, so it's loaded, so we're not assuming that all the outcomes are equally likely, so we can't just say 1/6. And we can't, in other words, we can't assume the uniform probability model. But a loaded six-sided die is tossed 1,000 times with the following results. So the number of times 1 occurred was 102, 2, 156, 3, 28, 21, 214, 113, 387. Find the empirical probability of each outcome. So the empirical is just going to be this number over 1,000, this number over 1,000, and so on, since we're tossing it 1,000 times. So that would be what? These numbers here. So normally we would say 1/6, but these are not all 1/6, but this would be the empirical model. Find the empirical probability of tossing an odd number with this die. So remember, odd number would be 1, 3, or 5, so we add up. Remember, we said the rule was to get the probability of an event, you add up the probabilities of the sample point. So 1, 3, and 5. So you would add up these numbers. So you'd get this. So it's only that. It's not a half. It's much less than a half. And then what's the next question? The probability of tossing a number greater than 4 with this die. So that would be adding up 5 and 6. So that's here. So it's 0.5. Okay, so this is not a balanced die, and we use an empirical model or an empirical method to obtain the probabilities. We don't use the a priori uniform probability model. Okay, here's some problems. So one of these is this one. Let's just check this one. Which of the following are valid probability models for an experiment. So what about A? So is this valid? And why or why not? So the point is that there are 4 sample points. These are the probabilities for the 4 sample points, but that's not possible, right? The sum of the probabilities has to be 1, but the sum is not 1 here. So this is not valid. A is not valid. How about B? Okay, what's wrong with B? They add up to 1, but it's still not right because we said all the individual probabilities must be between 0 and 1, but this is negative, so it's less than 0. So it's not between 0 and 1. So this is not valid. How about this one? Yeah, this is fine. They all add up to 1, and none of them is less than 0 or more than 1. And how about this one? Yeah, this works, right? So these two, the last two, are okay. They're valid. Okay, here's some more problems. Okay, the next section is basic theorems of probability.